Good afternoon, everybody. It is Friday, March 27th, 2020. Welcome to the end of week 2 in quarantine. Today I'm going to be talking about the lithosphere, rocks, and mostly minerals. You can expect that our lessons next week will be all about rocks. So we said yesterday the lithosphere is the crust of the Earth. It's basically the part of the planet that we live on. It is the crust in the upper mantle and it is made up of rocks, minerals, and soil. Now, I'm sure if I asked you guys what a rock is, you would all have some idea, and you'd probably all know what soil is too. It's like the dirt that the plants and stuff grow in. But what are minerals? So we're going to talk about minerals first. I'll use my fancy Galaxy pen. Minerals are solid, inorganic compounds. Now, let's look at that. We know that a compound is made up of 2 or more elements, and inorganic means that there's no carbon present. If there were carbon present, then that would be an organic compound. So, these are solid inorganic compounds. They are have a crystalline structure. Which means that they are very organized. And they have a repeating shape. And if I asked you to close your eyes and picture what a crystal looks like, you might say, oh, it's like a diamond shape, or it is rectangular with pointy on the end, because maybe you've seen a picture or you've seen crystals in museums. This is some other rock. Or a diamond shape, not like a diamond that is a square turned on the side, but like a diamond shape, faceted gemstone. Or even they can be like cubes. Of all different sizes. But the one thing they all have in common is that they are all very structured and organized. They have flat sides, right? So that's what a crystal would be shaped like. There are over 4,000 different kinds of minerals. And we use them for everything. Some things you can imagine right off the top of your head because I drew those pictures. So we use them for jewelry. Our pretty shiny rocks that you see on rings or on necklaces or on earrings. Salt is considered to be a mineral. The graphite that's in your pencil is considered to be a mineral. The fact that you're watching this on a cell phone or on your computer, there are minerals used in your computer chips. And we even use minerals for our general health. We need to make sure that we are eating our calcium, that we are getting our potassium and our magnesium. All come in dietary forms as mineral compounds. Most minerals of those 4,000 different kinds, most of them are made with oxygen or silica. In fact, these are called silicates. And silicates make up over 90% of the Earth's crust. So they are very common. Minerals are classified as silicates, or non-silicates. Our silicate minerals are quartz, feldspar, and mica. And some of our non-silicates are carbonates, like our calcium carbonate. These are in seashells. Sulfates. Like gypsum, which is used in fire retardation. It's non-flammable. And halides. Halides. These are found on the ocean floor. They form when seawater evaporates. And if you can see from the word halide, one of the compounds here are halogens. So elements like fluorine and other halogens in that column on the periodic table come together to make the halides. All right. How are minerals formed? Minerals, they can be formed basically through two processes. One, hot magma, or molten rock, or lava before it becomes out of a volcano. And we will be talking about volcanoes, and we will be talking about magma more when we're doing that. As a hot magma cools, then crystals are formed. This is how we get our crystals of quartz, for example. The second way that we can get crystals. Sometimes elements or compounds are dissolved in water. And as that water evaporates, crystals are left behind. In addition to this lesson, I'm going to put up a video because I made some crystals for you guys to look at. I will post the instructions on how to make the crystals yourselves if you so desire, but I'm not going to assign it as a lab. It's just kind of a cool project. So that being said, how of my 4,000 different types of crystals, how can I keep track of what kind of crystal is what? So, minerals, sorry, I said crystals. Minerals are classified based on a number of criteria. So it's basically, they're classified by their physical properties. What kind of properties would they be? If you said color, of course, that's the obvious one. They're going to group like minerals together based on color. But they also group them on how shiny they are. They are grouped based on their luster. How shiny. And of course, some things are very shiny. Those are metallic. And then they can be less and less shiny. They may look glassy or pearly or silky. They may not reflect anything at all, and so they are considered to be earthy. Think like clay or mud. They could be opaque, which I cannot spell today. It's OPAQUE. They could be translucent. Maybe I can see a little bit of light through it. They might even be transparent. I can see a lot of light through them. They're classified on the shape of the crystals that they form. That shape of the crystals tells a lot about what elements are making up the compound. They are also classified on how hard they are. So the hardness of the mineral. And they use a classification called the Mohs scale. I am having trouble writing this afternoon. Mohs scale. This is a relative ranking. Once upon a time, Mohs was a geologist, and he said, we should rate them on how hard or soft they are. We'll give them numbers 1 to 10. And talc, basically like baby powder, is the softest. That would have a rating of 1, where a diamond is one of the hardest materials known to man, would have a rating of 10. And then there's a list of other minerals that fall in between. That's how they rank the minerals based on hardness. They also classify minerals on, once you break them, what is the shape they make when they are broken. That's called the cleavage. What shape does my mineral make when it's broken? Does it have sharp edges? Does it still stay in its little square shape? What does it look like when it breaks? And the last physical property that's used for classification of a mineral is called its specific gravity. What the heck could that possibly mean? In the simplest terms, something's specific gravity is a question. Does it sink or float? So I said the density of water is equal to 1 gram per centimeter cubed, or 1 gram per milliliter of water. Okay? How does everything else relate back to the density of water? So what they want to know, does it sink or does it float? Is it more dense than water or is it less dense than water? So how does the density of a mineral compare to water? If its specific density is 1, then it has the same density of water. If its specific gravity, rather, is 0.05, then that mineral is going to float in the water. If its specific gravity is, I don't know, like 20 grams per mil, then it's going to sink in water. And every element, every mineral has its own specific gravity that is unique to that mineral. So that is our little talk on minerals today. And I will post the little video of the crystals that I grew for you. See you on Monday.